Chemistry, we're 19.3. So answers to the top of this. One is Rutherford was the first scientist that created transmutation. That was one of our words from yesterday. Down today on 31, just changing a radioactive element into another element, which may or may not be radioactive. Rutherford was the first human to cause that to happen. 2, a cyclotron is a tool that can be used to do that. Cyclotron, Iron Man built one in Iron Man 2 again in his basement to compose a new element there. Artificial radioactivity is 3. 4 is a positron. 5 is electron capture. 6 is a synthetic element. 7 are transuranium elements. I'll explain those in conjunction with peeking ahead at what the next quiz looks like. So next quiz, 19.4, has 4 new points, 4 fill-in points on 19.4. Relative to today's paper, 8 is still there, 9, 10, 11 to 28, that's all the same. 29, 30, 31, 32, 33, 34, all the same. Number 1 stays the same, just goes lower on the quiz. First scientist to do a transmutation is Rutherford, just go with that. 2 goes backward, it'll ask what a cyclotron does. It accelerates charged particles. They explain it pretty well in the book. I mean, it's operating on the principle that like charges repel and unlike attract, and trying to basically spin an electron faster and faster and faster and faster and faster until you can fire it at great speed. Another idea, not making the quiz, but just an idea here is that Rutherford and all these scientists that are trying to do this, there's a lot of particles that miss, but you only need one hit. So I mean, he's trying to fire all these electrons at something to get a hit. Electrons are tiny, so it's not that easy to hit something with an electron. But if you can get a hit, one hit is usually enough to do it, even though most of your particles end up being a big miss. 3 goes backward. What is artificial radioactivity? You could say radioactivity from a substance not found in nature, like man-made stuff. Positron 4 goes backward. You'll say it's a positive electron. Electron capture goes backward. You would say that the nucleus grabs an electron, and when it does, it converts a proton to a neutron. 6 and 7 just stay the same. Those are still fill-ins. Synthetic elements are any elements that are man-made, that aren't happening in nature on their own. Transuranium elements specifically are number 93 and up. 92 on the table is uranium, I think. Yes, it is. So anything that has a number higher than 92 bigger number of protons than uranium. Those are called transuranium elements. And then we have a new question represented here by my board, which is just duplicating page 573. So what you'll still be asked to do like yesterday is you'll still need to know the alpha abbreviation that we used in yesterday's homework. Still need the beta abbreviation that we used in the homework. Gamma won't have an abbreviation because it doesn't have a mass or a proton count. We're just going to use this symbol for gamma. But some new things that will make it in tonight's homework and on the next quiz is a shorthand way to represent a proton. This is the way that we can write a proton. It has one proton, doesn't have any neutrons, H for hydrogen. Neutron, this is the abbreviation for neutron you'll need for the next quiz. It has 0 protons and 1 neutron, so little n for neutron. Deuteron has 1 proton and 1 neutron for a total of 2 proton-neutron for the 2 mass. And we'll go an H for hydrogen because anything with a 1 on the lower level is an H for hydrogen. Hydrogens have 1 proton, atomic mass of 1. Our book is going to call this Triton or Triton. In the Spider-Man movie with Dr. Octopus back in the Tobey Maguire days, they were calling this tritium, and Dr. Octopus almost killed the whole city by chemical reaction kind of stuff. But that's a 1 still for hydrogen, but a 3, tri means 3, mass of 3. This is sort of like duo kind of stuff, total of 2. And then positrons made the quiz today, the positive electrons. So electron is this, positron, we just changed the negative to a positive, but still put the E for electron, positive electron is called a positron. But in the homework, on and off throughout the chapter, you're going to need to know those 8 code words. So tomorrow, these 3 will still be in the same question where they were when you're talking about alpha, beta, gamma. But then this group of 5 on the bottom will be its own question. Shorthand way for proton, neutron, deuteron, triton, triton, positron, those are on there. Homework coming from this, there's a 1PQR, there's a number 7, and then the majority of the work goes from 15 to 20, like what I'm just about to do. So I'm working from page 573, which is where the table was that basically is duplicated on the board. For 19.3, it says that oxygen 15 is going to have positron emission. Emission is code, but it goes on the right of the arrow. And if we're going to go positron, I need to grab this idea either from a board or from a book or from my memory or somewhere. But we have a positron adding on some sort of a mystery thing. To get the lower number from oxygen, as yesterday, use your periodic table. Oxygen is number 8. And then if you can add and subtract, you can make these numbers work. 0 is adding something to make 15, so that has to be 15. 1 is adding something to make 8, so that has to be 7. And then for number 7, you can use your periodic table to figure out number 7 is nitrogen. For 19.4, it's kind of the same kind of thing. It says strontium 82. So we need to know SR for strontium or look up SR for strontium. It's in the front of your book. There's a list of everybody's symbol. But strontium 82 has an atomic number of, where are you, strontium? 38. And it says it undergoes electron capture. This is different. They're not saying that we're emitting an electron. It's talking about electron capture. If you're capturing something, that is on the left of the arrow. Electron, we could go grab from here, electrons and beta particles, they share the same symbol. Beta was negative charge, it has the same symbol as electrons. So I'm going to grab that, and then I'm just going to do math. 82 is adding 0 to make 82. 38 is adding -1 to make 37. And then I need to use my periodic table to look up who number 37 is. And number 37 is rubidium. So RB. And that's what we're working on here on the 19300.